Hello and welcome to a deep dive into the layout-oriented storage control. Welcome to a new video of the series EWM Meets Automation, a series where I explain and show features, functionalities in and around SAP EWM MFS in cooperation with Swisslog. With this video, as I mentioned, we will look into the layout-oriented storage control. It will be a deep dive session. We will look into technical details of the functionality. We will look into the code again, and we will do this with focus on a MFS environment. That means, in this example here, it could be a pallet moving on a conveyor like this. So just being dropped on a conveyor and moving towards a pickup point of a high bay. So that's just one possibility, but the things that I explain are applicable to all areas where pallets or objects are moving across communication points in an MFS environment. Along with this, we'll also look at options for enhancement. So we look at the standard customizing, we will look at how the standard coding is processing it, but we will also look at options for enhancement in this context. Having said that, I will not give a detailed explanation about the concept of layout-oriented storage control as such. So if you are new to this topic, or if you want to get all the basics at first, I would recommend to have a look at this video here at first and then come back to that one, because I'm afraid that if you don't understand the basic concept, that you might not understand the technical details that I will explain within the next minutes. I will give you a very quick overview, and then we jump into the more complex stuff right away. So layout-oriented storage control, just as an example, I want to move from A to B. So for example, from the receiving area into a high bay, but I cannot go from there to the final bin in the high bay directly. So what SAP is doing is, when I create the task, I check whether I can go from A to B directly. If not, what is the intermediate step? So in this example, the handover to the conveyor. So I create an active task as an intermediate step and keep the one pointing to the final destination in a waiting status. So once this step is completed, there might be another step from the conveyor to the handover of the ASRS. So this task would be created, become active, would be confirmed, and the overarching task pointing towards the final destination is still in waiting status. Last step becomes active once there is no intermediate task anymore, and the waiting task points towards the final destination, becomes active, and is confirmed in this example by the SRS. Now that should really be it as an introduction here. As I said, the basics can be derived from the other video or blog post that I linked at the top here. Recap completed, LOSC understood, and we can jump into the technical details, and we start with the trigger. So where does the LOSC actually come into the game here, and when it is being called? The most important function module in this context is SCWM troute TL_dead. And this function module is called by FM SCWM routing_layout_check. And as you can see here in the stack, it is called in the context of HU warehouse task creation. The LOSC needs HUs. So when you create product task, and you will see that, for instance, if you create product tasks which are then confirmed or to be processed via RF, for example, picked into a pick HU, initially you won't see overarching task in waiting status, because initially the product task doesn't have a HU yet. Let's say the product task is not a HU task yet. So you pick the product to the pick HU on the resource, and then you have a HU warehouse task from the resource to the destination. Then you might get this intermediate step. So keep in mind, LOSC needs HU warehouse task, and the LOSC, the most important function module here, troute TL_dead, is called in the context of HU task creation, as you can see it here. So we will now focus on this function module and really take a step-by-step deep dive. As I said, we will concentrate on the MFS logic, but that doesn't mean that this content is not useful for you in case you are not in an MFS environment, because the non-MFS functionality is like a subset of the MFS functionality in this context. Yeah, the LOSC as a kind of MFS feature is also being applied to non-MFS processes. So that means you're just using a subset. So everything you need to understand about the LOSC will also, in case you're not using MFS, will also be part of the next minutes. So stay here even if you're not using MFS. That's what I wanted to say. So first step, I think most of you know the standard customizing for the LOSC. You will find it here in the warehouse task section. And what you do here is you fill a table with source data, destination data, and intermediate storage bins or sections or types. And that just says, I want to go from this source, from a type or for source storage group, to this destination type or storage group. And if I want to go from there to there, I cannot go directly. I rather need to go via this intermediate type, section, or bin. That's the main concept, as I explained in the beginning. And here, at the beginning of this function module, we are just selecting all the data for our warehouse from this table. That's the first step. Next one, from this whole bunch of data that we selected into our internal table here, we now need to select the valid records for our application. And that means we need to somehow access this table. So all of you, whoever asked themselves how this access is being executed, now find the solution here on the left side, and it is a hard-coded access sequence. So that means we do not have an option to customize the access sequence here, as we, for example, have it for the storage type search sequence or for the queue determination, where you can define in customizing, okay, at first I access with like all fields from the key, and then I access only with the warehouse process type or only with the storage type, and so on and so on. But instead of this, we have a predefined access sequence with 36 different accesses. And here in the coding of trout LDET, you find the sequence in which the LOSC standard customizing table is being read. And we select here one or multiple records. This is important to understand. Here with the sequence number, we have the option to define multiple records with the same key fields up until the sequence number itself, pointing towards different intermediate storage bins. This is not important in case you are not enhancing the standard, because the standard will always take the record with sequence number 1, but we will come back to this later. There is an option in standard to select multiple records and then use a body in order to tell EWM which of those records should be used. Third step, capacity check. This is mainly important in MFS environments because a specific segment of the conveyor or specific communication point may only hold a specific number of HUs. A conveyor has a specific length, and you cannot send more than X HUs, like cases or pallets or whatever, into the segments or onto this communication point if you don't want to cause a deadlock or traffic jam or congestion or something like this. So for this purpose, the LOSC executes a capacity check on the potential destination, so on the potential intermediate storage bins, using function module SCWM MFS _WT R2S CHK. So it reads the customizing of the segment and the communication point and takes the capacity which has been maintained in this data. Just a quick hint, if you're not familiar with these words here, with communication point and this MFS specific wording, there is a video explaining the most important objects in this context, which will explain, among some others, also the term communication point. I will put the link of the video also here at top and in the description. So here's just one more time a screenshot from where it is being taken. Here an example communication point, and here you see where you can maintain the capacity. And here's just a screenshot from the coding where the standard uses a subroutine here to determine the number of HUs, which are sitting on the respective segment communication point or moving from or towards the respective destination. And then here the check whether the remaining capacity is small or equal to the number of HUs, and maybe based on this the raise of an exception. Having said that, you have the option to maintain in the communication point whether only HUs without any active task are being considered, or also the ones at the communication point with an active task pointing away from the communication point, or even those with an active task pointing towards this communication point or this intermediate next destination. Yeah? And based on this capacity mode defined in the communication point customizing, there is different kind of calculation. So either the calculation here happens for the HUs with active task or without, and so on and so on. Now that's all happening here in the context of this function module. So standard reads the data from customizing, starts calculating based on the capacity mode, and at the end, you see it here at the bottom, calls a body. That's body SCWMX core LSC kappa. And in this body, you can also then override the decision from the standard with your own logic. That's also possible, and that closes this capacity check section. And the result of this is we have a list of potential destinations, and either one or multiple, as I explained before. And we know now whether one or all of these destinations have enough capacity to receive our HU or not. That's the result of this step, and we come back to this later, so keep that in mind. It's important later again. For now, the next step is first of all the prioritization of possible destinations, let's say records here in the context of the LOSC customizing. And this prioritization, as I said, is done in a body. Now the standard will always take the record with sequence number 1, but if you want to maintain multiple records here, you just give different sequence numbers, and in this body you can then decide which of those records should be taken. So if, for instance, you have a communication point, and at this point you want to route in a way that the first pallet travels left, the next pallet right, the next left, the next right, to kind of level the load for your system. And then in this body you might want to include a logic that checks which was the destination that the last pallet received. Okay, then I don't take this for the next one, so that you can implement some kind of flip-flop here. That's just a stupid idea, but that's how you can use it here. Or you say, I don't know, based on the HU information, for example, based on the HU type, or any other data from the HU header, you see it's imported here into the body. Any other data from the HU header is used in order to manipulate the decision of the LOSC record determination. So here in the key you don't have all the data from the HU header in order to make the decision, but here in the body you have the HU header. So you can basically make use of any data from the HU header in order to decide which LOSC record to be considered. And at the end, this body is importing a table of multiple records that had been read with different sequence numbers and gives you a structure with run record. So prioritization body, just to keep it in mind, takes different records with different sequence numbers and gives one record back which should be taken into consideration for the destination determination. Good. Next step is exception handling for capacity issues. As I said before, we come back to the capacity, and as I also mentioned that the result from the capacity check could be a list of possible destinations, and it could be that none of them has open capacity. So let's make it simple. We only have one possible destination, and this one possible destination is crowded. No capacity left. We cannot send the HU to this destination. So what can we do? A standard has different options here, and these options are also again then determined based on customizing that you defined before. So first option, we indeed create a task for the HU to move towards this destination, but we don't create a telegram. So we keep this task in KZ-SAP Y status. I explained in this video here that tasks are relevant for MFS handling in case they are assigned to an MFS relevant queue. So this is the case here, and in this case the field KZ-SAP from the ORDM-O table is filled, and this has a status of the telegram communication. So that starts with just being relevant, but no telegram created yet, and once the telegram is created and sent to the subsystem, it changes to X. That means the task is relevant for the subsystem and the telegram has been created. And in this scenario here, the task is indeed relevant, but we keep the status as telegram not being sent because we are not allowed, because there is no capacity. And then once capacity becomes available again, then these MFS background jobs will pick up this task because they know it's relevant, it's being flagged as being relevant, and then they will create the telegram for that task and send it to the subsystem as soon as the destination becomes available again. Second option is that we indeed create a task, but not to one of the destinations given in the LOSC customizing, but rather to a clarification bin. And this clarification bin again is maintained in the communication point where the HU is sitting right now. So HU is sitting here, says, I don't know where to go because there's no capacity. Then EWM says, okay, if you don't know where to go, then please go to the clarification bin. So it might be a reject where the HU is just looping or taken away from the conveyor, for instance. And the third option, we come back to this later, is we do not create a task at all. And then I will explain at the last step what we do in a case, in a scenario where we don't create a task at all here. Okay, finalization. Based on everything that I explained now, we only have two possible cases as a result. First case, we indeed determined the intermediate step. Based on the customizing, we found a record, and the intermediate destination is either free in terms of capacity, or it is not free, but based on the previous slide that I showed you, we decided we still create the task, but just don't send a telegram. So if this is the case, here we fill all the local variables with the destination, which is the intermediate bin in this context, and then we are done. The second case is that we did not determine an intermediate step at all. So the question is now, there was no record in the customizing table, for instance. So the question is now, do we throw an error, or can we activate the waiting overarching task? And in a non-MFS environment, in this scenario, we just activate the overarching task. But in an MFS environment, we need to do some checks before we are allowed to activate this task, which is waiting there. And the checks will be part of the next slide. So scenario number one is that the destination of the task which is being imported is customized as an endpoint or clarification communication point. So I included here again a screenshot of the communication point customizing, and here a screenshot where this check is being executed. And you see here those two flags need to be set in the communication point where we are looking towards right now. And if this is true, so it's an endpoint, a clarification point, then we are allowed to activate this waiting task and do not create another intermediate task again. If we look at an example layout, that means, for instance, the crane has removed the HU from the rack, dropped it on a conveyor, and it moved towards the conveyor and is now here at the decision point and needs to go to this outfeed here. Here's the end of the conveyor. So that would be an endpoint, customized as an endpoint, and that means if we are here, we don't need an additional entry in the layout-oriented storage control to go from here to there, because it's an endpoint. Scenario number two. We are coming from out of the conveyor from somewhere and move towards the infeed. So forklift drops the pallet on an in-feed, or we are coming from an in-feed and move towards the I-point. And those communication points, so the in-feed or the I-point, can be flagged as ID point. And if the destination is an ID point, like this, in-feed, or like this, I-point, forklift coming from here, dropping the pallet, or pallet coming from here, moving to the I-point, then we also don't need a record in the LOSC, so we can activate the waiting task right away and use it for this movement. Scenario number 3. Here is the part of the coding where this is being checked. We are still in troute L_det. And here it is about the source where we are coming from. So we are already at an endpoint. In the example before here, we are pointing towards an endpoint. And in scenario 3, we are already at an endpoint. And we are pointing towards some bin outside our automation. So in this scenario, we're also allowed to activate the waiting task and make use of it. That means we are allowed to activate the waiting task only in specific scenarios. And EWM will return an error and keep the waiting task inactive in case we could not find data for an intermediate step, like I said, and all 3 scenarios that I showed are not true. And so we could not find data for an intermediate step, and we are not moving towards an end or clarification point, are not moving out of the conveyor, and we are not coming like from an in-feed or pointing towards an I-point, and we are not at an endpoint and pointing out of the automation. If this is not true, EWM will return an error. If we don't find an intermediate step, one of these 3 scenarios needs to be true so that we can activate the overarching waiting task. And that also means that for all other MFS-related movements, we need to provide records in the layout-oriented storage control in order to avoid EWM standards throwing an error here. If you don't get it, get back to the slide that should explain it and read through it in a silent minute later again. At the very end, so basically after the step which I called finalization, finalization here in terms of EWM standard finalized its decision, we still have the option to overwrite everything. The function module body storage control layout calls body xcore LSC layout, and you see it here. It's exporting almost all kind of data that you could imagine in this context, and the body gives the option to change almost everything. So you can implement your full custom logic here. For instance, if you have special routing stuff for AGVs or monorail or robots, and there's some requirement which is not covered by EWM standard, you can make use of this body here. Done. So everything that you saw so far is sitting in this function module that I mentioned, and this is completed now and returned a routing decision. So to close the loop here, this function module basically gets a task for an HU which wants to move from A to B. MFS environment or non-MFS environment. And then this function module goes through all the steps that I explained, and at the very end it calls the body where you can change everything again, and then it returns a destination. So it might be the destination of the initial task, this overarching waiting task, but it might also be an intermediate bin. Now that's the result of this function module. Before I close and summarize everything again, I would like to mention one more thing, which is the error code. And the error code is written into the HU header in case we decided that the HU should move towards a clarification bin. And that is the case, or that was the case in the context where we could not find a destination with enough capacity, and we decided based on customizing that in this scenario HU should be moved to a clarification communication point. And if this was the case here, I showed this screenshot already some slides ago, we said this constant here is an error code. And if this constant is set, we are checking it here again, you see it over here. Then we write MFS error and we write into the field MFS error of the HU header an exception code. And based on this exception code, the HU will travel to the clarification bin of the given communication point. And with this concept, EWM allows the HU to basically travel on its own in a decentralized fashion from communication point to the other up until it reaches the clarification point. Because the HU always keeps this error in its head and arrives at the next communication point, and the communication point sees, okay, this is an HU is an error, just send it to the clarification point which is maintained in my customizing. And again, next communication point the same, up until the HU reaches the final clarification point, and there where it is processed in a way that the error is being reset or infeed again and processed again and reaches some part of a telegram processing or coding where the error is being reset and the HU can start again trying to find a OK destination, let's say. Just wanted to add this here as an appendix because there was no good spot to throw it in before. But that's also an important concept to keep in mind here. Last slide before I come for the summary. That's just one quick overview of the enhancement spot where you find all the 3 bodies that I mentioned within the last 20 minutes. They are all sitting in enhancement spot ES_core_LSC. So if you want to push in some custom logic here, that's the place where you want to check. We come to the summary as usual, a very quick review of what we did. At first, I explained to you very roughly the concept of the LOSC. And if you want to get more basic explanations here, please check the Understand LOSC video or blog post. I will link it here. Then we looked at this most important function module, which is doing all this stuff, which is called in the context of HU warehouse task creation, which is at first selecting the customizing and selecting the valid records from the LOSC customizing, checking the capacity against the possible destinations, checking the capacity mode, then prioritize multiple destinations if there are multiple ones. I showed you the sequence number in the key of the LOSC customizing table. Handle exceptions. So in case we only have destinations without capacity, we might decide to send the HU to a clarification bin or create the task without sending it to the subsystem. I showed you the different options. And at the very end, we create the task. So either we found a record for an intermediate bin, or we are in a scenario. I showed you different scenarios where we are allowed to activate the waiting overarching task without the creation of a new intermediate task. And all these can be enhanced based on the enhancement spot that I showed you on the last slide. So based on those bodies, you have the option to create 100% custom logic here. That's what we did within the last 20 minutes. I hope that you could learn something here, and I hope that I presented in a way that you could follow. It was not too quick and not too slow. I wanted to keep this a little bit shorter. That's why I'm speaking so fast. And to close this video, I would like to give you a quick outlook. I mentioned already the Understand LOSC video, which is a good addition to this video here. So for everyone who hasn't seen that, you should find it on my YouTube channel and on the blog. The next months will probably be a blog and a video about the I point. So what is an I point? What's happening at the I point from hardware perspective, and also what's happening at the I point from EWM processing perspective. Now that's another important topic to understand in the context of EWM MFS projects. And apart from that, I would like to thank Swisslog again for giving me the opportunity to publish videos about MFS topics here and making use of input coming from the EWM team at Swisslog. So in case you are interested in more stuff around SAP EWM integration with automation, and also if you are interested to join Swisslog, there are some open positions on their website, and there's also more information about the SAP topic on their website. I will put the links in the video description. And last but not least, I would be very happy if you would subscribe to my channel, because this is what motivates me here to create further videos, and this is also for you beneficial, as you will be notified automatically once the new video is released. That should be it for this video. I hope to see you back for the next one, and I wish you happy learning with everything else here. Thanks and goodbye.